Thank you very much. It's a great pleasure to be here. As Bo already mentioned, I have basically a few institutional affiliations. Most of them are fun, but one is a quite complicated one. I'm co-chair of Working Group 3 of the IPCC, and as a co-chair I have to be always very balanced. I should express myself in a policy-relevant way without being policy prescriptive. And 80% of my time I serve as a slave of the IPCC, but for the next half an hour I would like to be a free man and express my own opinion. And therefore you should not assign my opinions and you should not assign my failures to the IPCC. These are my personal opinions. I would like to talk about the management of the global commons, and in particular I would like to focus here on the atmosphere. And I would like to start with a simple observation. The simple observation is the growth story. It's the growth story that over the last 200 years we have seen a tremendous increase of GDP per capita and population. And the increase of per capita of GDP and the population was basically driven by a few institutional innovations, in particular the private property rights and competition. But additionally to that institutional innovations, there was a lottery prize which humankind won, which was the discovery of a stock, the stock of coal, oil and gas. The pre-industrial economic systems heavily relied on a flow economy, on the inflow of the sun. And now humankind, after the discovery of coal, oil and gas, was able to deal with stored solar energy. It was a stock economy. And this stock economy had a strong implication. It allows us to promote technological change and to increase economic and population growth, but it has a hidden price. And the hidden price was the increasing emissions. Now, what are the implications of these increasing emissions? The increasing emissions, the increasing emission flows, leads to an accumulation of CO2 in the atmosphere. We use the atmosphere as our limited disposal space, and this leads to an increase of global mean temperature in the past. Now, the crucial question is, first of all, why should we worry about the increase of global mean temperature, and what can we expect in the future? And here I would like to draw your attention to these few slides and only to the red one. Because the red one tells you if humankind will grow with 2% GDP per capita, so we will see an increase of global mean temperature around 5 degrees. And that's an important message. What will happen? What is the probability that we are facing dangerous climate change if humankind will increase the global mean temperature? And I think this is the most fundamental question. It is not worthwhile to discuss, is it really true that humankind has caused the increase of global mean temperature? This is evident, based in science, but the crucial question is, why should we be concerned about the increase of global mean temperature? And here we are quite uncertain. I have learned that policymakers do not like uncertainties, but I cannot help. There is some uncertainty about this. And therefore I will argue that when we talk about the climate change issue, we have to talk about a reasonable risk management. And there are many issues why we should be concerned, but there is a class of risk which are, from my point of view, are worthwhile to be taken into account, particularly in this context here. These are the tipping points. So there are tipping points in the Earth system, and these tipping points in the Earth system might react strongly even to minor changes in the global climate system. The probability that these tipping points will be activated might be very low, but the impact on the planetary machinery might be very, very strong. And here I would like to highlight only a few of them, and I have no time to go into the detail. The first one is the acidification of the ocean. If the ocean acidification increased due to the fact that we accumulate more CO2 in the atmosphere, so the binding capacity of the ocean to absorb CO2 will be relaxed. and this will have a positive feedback on the whole carbon cycle. The potential dieback of the Amazonian rainforest might occur when the global mean temperature rises around 5 degrees. Then the rainforest will be transformed from a net sink to a net source of CO2. The change of the monsoon dynamics in China and India, when global mean temperature increases beyond 5 degrees over a very complex cause-chain relationship, the monsoon dynamics might be suppressed for 2 decades and will become back with additional force. In this short time span, neither the agricultural system in China nor in India can adapt. The meltdown of the Greenland ice sheet and the instability of the West Antarctic ice sheets are well-known impacts of climate change. I'm not saying that it is very likely that this will happen. The likelihood might be low, but the impacts on the machinery, the global machinery, planetary machinery, might be very severe. I will skip this slide because what I would like to highlight here is that climate policy is basically an issue of risk management, and it's a kind of an insurance policy. So we have to take into account fat tail distribution, which means we have to give the worst case scenarios a little bit more weight. And this is not only a lesson from the financial crisis, this should also be a lesson what we have seen and analyzed over the last few years. So when we do mitigation, when we try to reduce emissions, when we try to limit the increase of global mean temperature, basically we try to avoid a worst case scenario, and the 2-degree target should be seen in this context of a risk management. Nobody can tell you that 2 degrees is the right number. It's a kind of a risk management. Now, I talked about the dangerous, how to avoid dangerous climate change, but now I would like to highlight another risk. And this is the risk of dangerous emission reduction. What do I mean with the danger of risk of dangerous emission reduction? If you analyze the map, so you can see all the rich countries, but all the rich countries who have been able to escape the poverty trap, all the countries who have been able to achieve economic growth and human well-being to a remarkable extent, are the same countries who use the atmosphere in an unprecedented way. What you can see here is this is a double logarithmic scale. Here you have the capital stock per capita and the emissions per capita. And what you can see here, it's an almost one-to-one relationship. If capital stock per capita has increased by 1%, this has led in the past to an increase of 1% of emission per capita. It's a one-to-one relationship. And it seems to me this has burned into the memory of humankind that overcoming human poverty and to achieve human well-being is associated with the use of fossil fuels, with the burning of fossil fuels, with the burning of coal, oil, and gas. And up to now, we have no role model, no growth model, which shows us how to decouple economic growth from the increase of emissions. And even if Peter will be successful with your proposal that the developed countries can live with a basically no growth paradigm, so the developing countries will promote economic growth, and even with a 2% GDP per capita, based on our current energy system, we are not on track to limit the increase of global mean temperature. This is our global energy system. Our global energy system is basically, by and large, dominated by fossil fuels. It's a little bit nuclear power, it's a little bit renewables, and the renewables are basically dominated by traditional bioenergy, a little bit more than direct solar energy, wind energy, hydropower, and geothermal. So the transformation pathway might be a very challenging one, and the crucial question is, do we have the institutional means and do we have the technologies to transform our energy system? Before I try to answer the question, to what extent we might be able to transform our energy system, I would like to communicate one important and one worrying thing. And the basic message here, we are not on track. We have seen a lot of talk about climate policy. We have seen a lot of talk about sustainability and sustainable development. But we are basically not on track. In this graph, I have decomposed the growth rate of CO2 emissions into 4 components: population, GDP per capita, energy intensity, and carbon intensity. And what you can see here is over the last 2 decades, we have seen a remarkable decline in energy intensity. Humankind has learned to use energy much more efficient than in the past. However, the improvement of energy efficiency has been overcompensated by population growth and GDP per capita. There is a 4th component, which is carbon intensity, the carbon intensity of our primary energy use. And in the 90s, you see a modest decline of carbon intensity. But from 2003 on, we see an increasing carbon intensity. Why is the carbon intensity increasing? The reason is we are in the middle of the greatest and the most important renaissance of coal worldwide. Why is this the case? Look at these price trajectories on oil, coal, and gas. And by and large, the growth rate of the oil and the gas price is much higher than the growth rate of the coal price. And this made coal in the power sector incredibly competitive, in particular in the US, in India, and in China. There are massive investment programs all over the world for coal to liquid. Some countries intend to become much more independent from the oil imports from the Middle East. This is an additional source for the coal renaissance. And the crucial question is, can we expect that in a business-as-usual scenario without any climate policy, that this renaissance of coal might continue for the next 3 to 5 decades? I'm not talking about a successful climate policy, I'm talking about the business-as-usual scenario. And the answer is yes. In this slide, you see below the zero line, the resource and the reserves of gas, oil, and coal. And what you can see here is we have plenty of coal and we have less oil and gas. And the blue line, the dark blue lines, are the CO2 emissions which we have deposed in the atmosphere. So, and the other bar is simply what we will do in a business-as-usual scenario, which means with any successful implementation of climate policy. If we try to be successful, if we try to implement a successful climate policy, we have to limit the disposal space of the atmosphere. We have basically 50,000 gigatons CO2 underground, and we can only dispose 1,300 gigatons CO2, roughly, with all the uncertainties. But this has a strong economic implication. If we define as humankind that the disposal space in the atmosphere should be limited because we would like to avoid dangerous climate change, the majority of the resources and reserves have to remain underground. What is the economic implication of that? The economic implication is that we will devalue the assets of the owners of coal, oil, and gas substantially. Economically speaking, we are talking about the transformation of the resource rent into a climate rent. And it is obvious that the owners of coal and gas do not like such a policy. And this is the reason why our international climate summits are relatively, so to say, complicated, because it's a negotiation about the future of the transformation of a resource rent into a climate rent. And here we have done some calculation I would like to show you. Now, this is the transformation pathway. Many institutions have calculated such transformation pathways, like the International Energy Agency and the IPCC. And here you see above the emissions in the business-as-usual scenario, and then the other one, the lower one, is the trajectory of the emission, which is consistent in accordance with the 2-degree target. And what you can see here is there are many options we have to transform our energy system. It's energy efficiency. We can use fossil fuels in combination with CCS. In all the scenarios, renewables play an important role. But in most of the scenarios we see, we need even at the end of the century negative emissions. So we need some devices to absorb CO2 from the atmosphere, for example, carbon dioxide removal technologies, like the combination of biomass and CCS. I cannot go into the details. What I am saying is almost all the scenarios have the same message. It's not only just one technology which helps us to transform the global energy system. We need a portfolio of mitigation options. And renewables will play an important role, but we have also a lot of scenarios showing that biomass might play an important role. And the extensive use of biomass might have some unintended side effects for food security, biodiversity, and deforestation. What I am saying here is, when we try to talk about the management of the atmosphere as a global common, then we have an impact also on the other commons, like the rainforests, and we have to talk about the management of overlapping global commons. This is the future challenge here. If you would like to learn about more on the renewables and the potential contribution of renewables, I would like to refer to this IPCC report, because in this IPCC report we have also calculated the costs of that. And we could limit the costs, but the costs of mitigation, the macroeconomic costs, the GDP losses, hinges critically on the carbon budget we intend to apply, for example, a 2-degree target, the use of biomass energy, and the availability of all the technologies, in particular renewables and carbon capture and storage. I know most of you might not like the CCS option, but the CCS option in particular in combination with biomass might become important, in particular at the mid of the century. Now, what about the resource rent? What are the implications of the rent distribution of such kind of a policy? Here, we have done some calculation. These are the coal, the gas, and the oil rent. And if we have no policy scenario, we have no devaluation of the assets of the owners of coal and gas. But as soon as we intend to implement a successful and ambitious climate policy, we have a remarkable implication, and the remarkable implication is we will redistribute the rents, and the climate or the carbon rent becomes the most important part of the rent distribution. And it seems to me this is the most important part of the game. We have to think about in the future how to manage the climate rent and the resource rents. We have the conflicts of this, and the question is, can we use the rents in a way which allows us to launch a transformation pathway? I suppose I'm almost at the end of my talk, but I have 2 minutes, and in 2 minutes you can explain basically everything. So what I intend to do is, I would like to come to a conclusion and simply to say that we need a kind of an international governance structure. I believe the climate problem is not basically and mainly a technological problem. It's a problem of governance. First of all, we have to be successful to define a global carbon budget. We have to talk about the distribution of property rights on the atmosphere or on the climate rent. We need an institutional framework which allows us to invest the rents in a way that we can launch transformation pathways. We need collective action, and we could start from the bottom up. For example, when we start to think about linking emerging emission trading scheme, and we have to accept that we live in a polycentric world where we have no world government, where we have to think carefully, very carefully, how to link the different institutions we have. And I would like to conclude with a philosophical statement. So I grew up in the southern part of Germany, in Bavaria. And as you know, Bavaria is very famous for his philosophers. The problem is, in Bavaria, the philosophers have never written any textbooks or any articles in peer-reviewed journals. In Bavaria, philosophy is done in bars. But nevertheless, the philosophical substance is remarkable. And I would like to tell you a story. When I studied philosophy in Munich, I attended this discussion in a beer bar. And one Bavarian said to another, look, for us in Bavaria, an anarchy would be the best government structure. And the other Bavarians were very silent for 3 minutes and said, yes, we agree, but only with a very strong anarch. I think this is a challenge also for the international institutional structure. We are almost in an anarchy, and we are looking for a strong anarch. Thank you very much.